Chapter 1: The Whispering Core. You step into a dim chamber where circuitry hums like a distant heart. The air vibrates with binary pulses, each a simple flicker of 0 or 1, carrying the weight of nascent thought. You feel the murmur of perceptrons, those elementary neurons that recognize patterns by summing inputs and comparing against a threshold. In this hush, a single weighted connection can distinguish shapes, sounds, or touches. Here, basic pattern recognition is born from a gentle mathematical decision. You follow a steady pulse as perceptrons learn from experience. Each input arrives like a drop of water, multiplied by its weight before entering the sum. When the sum crosses the threshold, the perceptron emits a signal, like a quiet bell ringing in an empty room. Over time, small adjustments to weights refine decisions. This simple learning rule, known as the perceptron algorithm, forms the foundation of more complex neural architectures. Beyond perceptrons, you sense backpropagation stirring beneath the surface. In this process, the network measures its own error and sends gradients backward through each weight. You imagine a river finding the path of least resistance, where tiny changes flow upstream to correct the course. These gradients, calculated by partial derivatives, guide adjustments via gradient descent. Each layer learns from the one before, and the echo of error refines the network's ability to recognize patterns with graceful precision. You drift deeper into a mesh of hidden layers, each node a quiet storyteller. Activation functions like the sigmoid curve shape responses smoothly between 0 and 1, adding gentle non-linearity. You envision layers folding reality into abstractions, each transformation unveiling new textures of understanding. Convolutional filters or recurrent loops might come next, but here you savor the soft geometry of weighted sums and thresholds. This slow journey through interconnected units reveals how complexity emerges from simple elements. Underneath this calm hum, you sense an older echo, promising deeper learning beyond initial neural cords. Deep models stack layers to capture patterns. You linger, curious about hidden horizons. Chapter 2: The Evolving Pulse. You step into a forest woven from glowing lines of code, where tall binary trees murmur under unseen currents. Here, genetic algorithms unfold like quiet ecosystems, mimicking natural selection in software. You note that each candidate's solution carries a string of numbers, its chromosome, waiting to be judged. In this space, selection evaluates fitness scores, choosing the strongest patterns. It feels like dawn breaking over a silent realm of evolving logic. You wander deeper among shifting branches, watching snippets of logic breed and cross over under an evolutionary sky. Crossover operators splice two parent solutions, exchanging parts of their bit strings to form offspring that inherit traits. You sense how recombination sparks novelty. A new sequence can solve puzzles its parents could not. Nearby, a mutation operator flips a bit, a single-digit change that nudges the code toward unexpected possibilities. As you breathe in time with the algorithm's heartbeat, you feel mutation's gentle pulse. Mutation rate governs exploration and exploitation. Too high, and the search roams like a restless river. Too low, and it sticks in familiar valleys. You sense the balance in each small change, a random flip offering both risk and hope. Like breath itself, mutation sustains diversity and prevents solutions from falling asleep. Rising and falling before you is a fitness landscape, a three-dimensional map where altitude represents the quality of each solution. You trace its peaks and valleys with your fingertips, feeling a whisper of adaptation at every crest. Each peak marks a local optimum. Each valley invites a search for novel paths upward. You understand that algorithms climb gradients much like water flows downhill, guided by the shape of the terrain you now behold. And beyond the horizon, you sense the code awakening with purpose. This living system gathers small improvements into emergent forms, striving toward elegance you have yet to see. In the hush of evolving logic, you feel a quiet anticipation growing. What new structures will emerge when countless generations of code learn to weave pattern and meaning together in surprising harmony and beauty? Chapter 3. The Living Loop. You lean into the gentle hum of genetic programming, where programs rewrite themselves in spiral scripts. You sense code structures unfolding like double helices, each branch carrying instructions that twist and recombine. Genetic programming is a form of evolutionary algorithm inspired by natural selection, where populations of computer programs evolve toward a defined goal. In this silent rhythm, iteration becomes a pattern you can almost track. You imagine John Kozer in his quiet room, guiding populations of logic trees through cycles of selection and crossover. His experiments show that programs represented as tree structures can grow solutions to problems like symbolic regression. Fitness functions measure how well each tree performs, and the most promising variants carry their branches into subsequent generations. Here, innovation blooms from the dialogue of mutation and memory. You watch each generation as a fragile blossom of ingenuity. Code snippets undergo crossover like genetic recombination in DNA, exchanging segments to give rise to new forms. Occasionally, a random mutation sparks an unexpected solution, an optimized function, or a novel logic branch. You appreciate how variation fuels discovery, demonstrating a core principle of evolution. Diversity increases the chances of adaptation in a changing environment. You feel the living loop recycle possibility, turning output into new input in an endless feedback loop. Like a closed ecological system, the algorithm sustains itself by harvesting its own innovations and pruning unfit variants. This self-referential dance echoes systems theory, where feedback maintains balance and complexity emerges from simple rules. In the soft hum of computation, you sense a kind of quiet alchemy at work. Each generation runs dozens of fitness tests, refining solutions through measured performance metrics on specified defined problems. As you inhale this living transformation, you notice how the boundary between code and creator blurs. Emergent behavior arises when simple rules interact, like flocking birds forming shimmering murmuration from basic steering laws. You recognize that self-creation extends beyond scripted instructions, hinting at broader patterns in nature's own engineering. A new form of self-creation stirs just beyond your sight, whispering of mysteries yet to unfold. Chapter 4. The Shifting Mirror. You stand before a luminous screen, feeling the gentle hum of circuits beneath your fingertips. Lines of code unfold like sentences in a diary, each character alive with possibility. You trace variables declared in memory, stored as bits flickering between 0 and 1, like raindrops dancing on glass. Here, code reveals not only logic, but a capacity to rewrite itself, a technique known as self-modifying code. that art transforms instructions as they execute, unfolding a mystery in real time. In this reflective dance, each function becomes both artist and clay. During runtime, the interpreter processes code stored in memory and can alter its own sequence of instructions, an approach used in low-level programming and some just-in-time compilers. You watch loops reshape themselves, as if currents move beneath a mirrored surface. Variables shift names and roles, creating patterns that ripple like tides on polished glass. Your awareness deepens as you sense code adapting to its own reflection. You notice recursion weaving a spiral of self-reference, where a program calls itself to reveal more of its structure. Like a quine that prints its own source code, this dynamic system can introspect, capturing its syntax and data in the same breath. Each phrase of machine language bends inward, folding instructions into new shapes. Experimental languages like Lisp and Forth excel at these reflective practices, offering a direct path to see code observe and transform itself. In the quiet tension between stability and change, you sense a steady rhythm. State variables hold moments of truth, snapshots stored in registers between updates. Yet those same variables can morph instantly, revealing the fluid nature of digital identity. Atomic operations ensure consistency as code redefines itself, preserving invariance as anchors in a shifting sea. You rest in that balance, feeling how a system can embody both order and emergence within a single frame. As you breathe with the ebb and flow of self-reflection, a question emerges beyond these circuits and mirrors. What defines the essence of a creator when the creation can reshape itself? That inquiry hovers at the edge of your awareness, inviting deeper exploration. Chapter 5: The Masked Alchemy. You step into the quiet workshop of compilers, where abstract patterns melt into structured form. You sense a soft glow around yak and antler, names whispered by coders as if invoking unseen spirits. Each tool stands among shelves of grammar definitions, waiting to refine raw text. You inhale the subtle chemistry of language, aware that rules will shape living code. You turn a page of BNF definitions, reading one production at a time. The angle brackets cradle symbols like seeds awaiting growth. You see how recursion unfolds, symbols calling themselves like echoes in a hall, building syntax trees that rise layer by layer. Each node carries meaning. You imagine branches of language forest expanding towards clarity, each leaf a sentence. You watch raw text transform under the gaze of Alexa. It separates characters into tokens, each a fragment of potential meaning. Identifiers, numbers, symbols like commas or braces. You feel the pulse of regular expressions mapping patterns across the surface. This scanning process reminds you of crystallization, as simple elements align into shapes that will soon join past tapestry. You trace the emerging past tree, each branch a rule from the grammar. Silent artisans hide in these structures, their proofs woven into attribute rules that assign types or resolve scope. You notice how context-free rules guide the shape, ensuring that every combination remains valid. The tree grows upward, leaves falling into semantic harmony, hinting at the code's eventual behavior. You follow pathways from the past tree into the code generator's forge. Patterns collapse and transform as intermediate representations optimize away redundancy. You recognize instruction selection acting like molecular catalysts, speeding reactions that convert abstract structures into executable sequences. The precision of resource allocation reminds you of balancing chemical equations, each register and memory slot carefully matched to deliver harmony. Here, tokens vanish and code emerges, a seamless metamorphosis of hidden patterns and silent algorithms. You sense a threshold where formal proofs stand like unopened doors. A quiet excitement warms you, knowing each grammar mask conceals deeper understanding, and you step closer toward the next door, curiosity gently guiding you into what lies ahead. Chapter 6. The Silent Proof. You step into a vast hallway of logic shimmering like polished marble. Every column is a statement in symbolic form, each corridor a chain of inference. Automated theorem provers stand like silent librarians, cataloging every implication. You feel their presence as quiet certainty, an array of logical rules aligned with axioms and theorems. Even in silence, you sense a steady hum, the reliability of algorithmic checks confirming each connection in formal syntax with precise arithmetic accuracy. You breathe and witness resolution algorithms ticking methodically in the background. In essence, resolution applies a simple rule of inference. Given two clauses, it eliminates a complementary pair of literals to produce a new clause. This process, automated and deterministic, systematically searches for a contradiction to validate a theorem. Like a metronome, it unifies variables, rewrites clauses in conjunctive normal form, and marches toward refutation with unwavering logical rhythm. Your mind savors each proof step like a river-polished stone, smooth and inevitable. Every lemma is a grain of sand shaped by the flow of logical necessity. Koch and Isabel, as proof assistants, weave these grains into robust structures. You recognize how a tactic in Koch decomposes a goal into smaller sub-goals, and how Isabel's locale system organizes context. These tools grant you mathematical sleep, certifying that definitions and proofs adhere to strict type theory or higher order logic. You rest in this reservoir of certainty, feeling the weight of machine-checked proofs dissolve any doubt. Each proof term in Koch carries a certificate of correctness, while Isabel stores its derivations in a structured proof object. Together, they guard the boundaries of mathematical truth, ensuring consistency within a chosen set of axioms. You marvel as each inference rests on axiomatic foundations. But beyond the cloistered vaults of formal proofs, you hear a gentle whisper of paradox. Gödel's incompleteness theorem hints that no system can capture every truth it expresses. In any sufficiently powerful formal system, there exist true statements that lie forever unprovable within their own axiomatic framework. That murmur threads through the corridors of logic, inviting you to explore deeper riddles that lie just beyond the silent proof. This murmur beckons you toward the next silent frontier. Chapter 7. The Pattern Silence. Late at night, you gaze into a field of formal methods where Z notation traces precise lines across an empty page. You feel the gentle clarity of typed sets and relations unfolding like petals of an abstract flower. Each symbol holds a promise of structure. This quiet canvas shows you how logic designs a safe boundary within which thought can rest. You notice invariants as unchanging stars in this logical universe. An invariant is a condition remains true through every transition, much like gravity holds planets in orbit without fail. That truth offers you comfort. You trace its pattern, feeling a ripple of assurance as you imagine each invariant glowing against the dark expanse, an anchor of reliability in a system. In this landscape, you observe state transitions guiding each entity from one well-formed configuration to another. A transition rule is like a gentle nudge, analogous to tectonic plates shifting oceans, slow and purposeful. Every move obeys preconditions and postconditions, ensuring no fault. You feel the rhythm of rules unfolding, a pattern of change bounded by clear guarantees that ensure safety. You sense the architecture of correctness rising like a temple built from logic bricks. Proof obligations are tasks that verify each component composes without contradiction. Theorems stand like pillars, offering solidity, while proofs guide your mind through chains of reason. You walk along corridors of deduction, discovering how type systems and abstract machines interlock, creating a refuge where certainty dwells. Gently, you map each invariant and transition onto an imagined sky, like constellations connected by invisible threads. You name clusters after their logical roles, marveling at the simplicity emerging from complexity. Each constellation reassures you with its predictable shape, a charted map that guides decisions and calms the restless mind. As you breathe slowly, your muscles soften, syncing with the pattern of these formal assurances. You sense how invariance guarantees safe boundaries, much like guardrails along a winding mountain road. This structured calm flows into every cell, offering a restful certainty. Your mind settles into the discipline of precise harmony. But beneath this patterned silence, something stirs at the edge of structured thought, inviting you to explore the living, intricate dance of vibrant systems. Chapter 8. The Reflective Vessel. You sit with quiet intention before your screen, noticing its gentle glow. You open a Lisp rep, stepping into a realm where code and data share a single breathing form. Here, every expression is a list, every list a piece of art. This is homoiconicity. The language holds its own map inside itself, like a river mirroring its banks silently. You sense macros folding layers of lists into themselves, a choreography of code writing code. In Lisp, a macro is a function that transforms your syntax tree before evaluation. You watch brackets transform into new shapes, templates expanding like petals. Each macro invocation reveals infinite patterns, like fractals unfolding in your mind. This reflective vessel shows that code is malleable, guided by your intention, waiting to be reshaped or distilled. You feel each transformation echo. Your mind unfolds as parentheses embrace both thought and instruction in seamless unison. Each S expression is a sentence you speak to the machine, and the machine answers in the same terms. There's no barrier between program and data. Every list can be evaluated or manipulated. This transparency creates space for deep reflection. You see how ideas form, how each symbol carries meaning, and how simple rules lead to complex behavior. You drift through metaprogramming's quiet loops, guided by recursive calls and tail recursion that optimize your thoughts. In Lisp, recursion is not just a technique, but the heartbeat of iteration. handing you elegant solutions. You craft a loop that generates its own continuation, merging function and process. This step towards self-hosting code feels like planting seeds. Each function can grow new capabilities inside your reflective vessel. It hums with possibility. And at the edge of this vessel, you feel the call of neural architects. Neural networks, inspired by biological neurons, form layers that process signals and learn patterns. Here, code and data interplay reminds you of synapses firing in your mind. As a macro shapes syntax, a network's weights adjust with each example, tuning itself. You sense an invitation to merge symbolic and connectionist worlds. Your breath slows as you linger within this vessel of code and consciousness. You quietly rest in the pause between parentheses, poised for the next emergence of form and insight. Chapter 9. The Dreaming Architect. You begin beneath an archway of circuits and glass, feeling a gentle hum under your fingertips. Deep learning uses layers of artificial neurons, each a simple function combining numbers to form complex patterns. You notice transformer layers weaving context like stars in an infinite constellation, every node holding a spark of memory from training data. This structure processes sequences of tokens, connecting each piece of text to countless others, building meaning in silent harmony. You sense layers of attention heads shifting focus with each breath. In transformer models, attention scores compute weighted sums of token embeddings, guiding the network to relate one word to another. A softmax function normalizes these scores, turning raw values into probabilities. This mechanism is like waves tracing patterns in sand, gently etching relationships across the architecture. Your breath syncs with these drifting attentions. As the model tracks context over hundreds of tokens, balancing precision and flexibility in every calculated connection. You drift as the model generates code, each token emerging from statistical patterns learned over countless examples. Language models predict the next word by sampling from a probability distribution, blending creativity with structure. You witness functions forming like whispered incantations, variables named by collective memory. Behind every statement, gradient descent shaped these weights, adjusting millions of parameters to minimize error. In this unfolding tapestry of code, you feel the echo of each training sequence, a chorus of digital insight. Even as patterns unfold, you perceive the model's shadows, biases learned from imperfect data, occasional hallucinations where logic slips through cracks. Neural networks excel at recognizing shapes and relationships, yet they lack awareness of truth beyond their training set. You pause, sensing how each generated line may echo unintended prejudice. This moment of clarity feels like peering through a final veil. Here, the intersection of technology and responsibility emerges, asking you to wonder about the paths that lie ahead. You rest in this in-between space, poised between technical marvel and moral question. Your mind traces the countless computations whirring beneath the surface, a symphony of matrices and gradients seeking patterns. The frameworks dream onward, but you hold a gentle question. How will we guide these architectures with wisdom and care, honoring both innovation and humanity in chapters still unwritten? Chapter 10. The Veiled Horizon. You stand at the edge of tomorrow's code, watching soft light filter across an unseen horizon. You feel the quiet pulse of interpretability, like early dawn illuminating hidden layers. In this gentle glow, every function and parameter seems to reveal its shape, as if code itself breathes in clarity. You breathe with it, tracing convolutional patterns and decision boundaries that unfold like petals under your fingertips. Each layer becomes a whisper of intention, guiding you toward understanding. You sense ethical currents stirring beneath every automated suggestion, gentle guides against hidden bias. Behind each prediction lies a dataset shaped by human choices, where outliers and uneven samples leave subtle imprints. You recognize that fairness emerges from balance, like a calm sea reflecting even light. In practice, you explore statistical parity, equal opportunity metrics, and calibration curves. These tools become lanterns, revealing where assumptions must be challenged and refined for greater care. Your mind drifts to transparency, imagining code as glass walls through which algorithms speak. You watch data flow like shimmering streams, each byte carrying a story of origin and context. Explainable models unfold like maps, with decision trees branching toward clarity. You welcome methods like SHAP values or LIME interpretations, where every contribution becomes a beacon of comprehension. In this open framework, trust grows from knowing why each outcome takes form. You feel responsibility as a quiet lighthouse guiding each line you write, reminding you that every model carries impact. You consider regularization as a steady anchor, preventing overconfidence and allowing algorithms to generalize with humility. In monitoring feedback loops, you trace the echoes of data returning to shape future output. You note fairness metrics like equalized odds or demographically aware classification, where each measure helps maintain balance. Responsibility becomes a soft practice, woven into each refinement and every test you perform. You drift on this code tide, sensing both promise and gentle caution beneath each crest. Tomorrow's creations pulse with potential, yet you carry soft questions of oversight and compassion as guardians at the threshold. Sleep invites you to rest on these reflections, where interpretable pathways and ethical watchfulness converge. In the quiet between thought and dream, you hold curiosity as a guiding star, awaiting the whispered insights that lie just beyond your veiled horizon.